In this video, I would like to introduce several remote sensing systems or sensors using linear arrays. Okay, the systems and sensors include spot system from Europe. Okay, and also several sensors with very high spatial resolution. Okay, they are all commercial satellites. So, spot system is actually used to be as famous as Landsat. Okay, you can consider spot systems. They are the European version of Landsat because spot systems they are also they were focusing on the land resources. Okay, I said they were because this family ended in 2003 after the launch of Spot 5. So there is no more Spot satellite anymore. But today, Landsat 8 is still in the sky. I'm not sure if there will be Landsat even 9 or 10, but Landsat is still there. Spot is not history, but we're not seeing more new satellites. Okay, it was the first spot sensors. The first spot satellite was launched in 1986 by the French Center National. The last part I don't know. It's French. Okay, and the full name of this satellite is also French, but the abbreviation is SPOT. So there are 5 SPOT satellites, and the first one was launched in 1986, and the last one was launched on May 3rd of 2002. So let's check out the Spot satellite. A very special part about Spot satellite is that each satellite has 2 sensors, 2 HRV or HRVIR sensors. You can say here is the first sensor on the right side of the satellite. There is another one on the other side of the satellite. Okay, all spot satellites they are using they use sun-synchronous orbit, and this inclination degree is for their orbits. Okay, and for each sensor. Another special part about spot satellite is that each sensor can have 2 modes. One is scanning nadir area, which means the area right below the sensor, the satellite. And each sensor also has an off nadir model, or say off nadir mode, that can just scan another line that off the nadir. Okay, the off nadir on commands could be positive or negative 27 degrees, which means that that sensor can rotate a little bit. Okay, to not only scan the area right below the sensor, but also some area away from the nadir of the sensor. So up to 80 kilometers swath of nadir. Okay, and 2 sensors cover 117 kilometers. You will say, okay, we have 2 sensors. At nadir, each sensor has a skyline with a swath of 60 kilometers, right? So 2 sensors, it should be 120. Where is the other 3 kilometers? I'm going to tell you that later. But for now, the revisit time for Spot 5, you just need to memorize this, is 2 to 3 days. It's relatively short, okay? And here is why. Why it's not 120, it's 117, because there is a 3 kilometer overlap between these 2 sensors, okay? So here we have Skyline 1, Skyline 2, they belong to 2 sensors, then there is an overlap between them. And Spot, each satellite has a 26 days revisit for nadir track. But like I said, Spot satellites, they can look sideways. Sensors on Spotlight satellites, they have off nadir scan track or scan line, which means that even even the satellite is not right above a specific area, it is on another orbit that is away from this area. It can still use the off-nadir mode to scan the area of interest. This makes the actual revisit time of a specific area much shorter than 26 days. Usually it's 1 to 4 days. Okay, so that's the special part about spot satellite. You need to wait for 26 days to have the same spot satellite fly right above you. But since a spot satellite can just scan your area from another direction using what off-nadir mode, so the actual revisit day, the revisit time is 1 to 4 days. Okay, so 26 days is pretty long, right? But using off-nadir mode, okay, the revisit time can be decreased dramatically from 26 to 1 to 2 or to 1 to 4 days. Okay, and here is a comparison between Landsat TM, MS, and spot image in terms of what? In terms of the size of each image. You can see that each spot image only covers a 60 kilometer by 60 kilometer area on the surface of the Earth. A Landsat image is covering much larger area, and it's not a strict what square. It's actually 170 kilometers by 185 kilometers. And spot, we have spot 4 and 5. They are advanced versions of spot 1 to 3. So the improvement includes spatial resolution. Okay, improved from 10 meters to 2.5 meters in panchromatic model, and 10 meters instead of 20 meters in the visible and near infrared in multispectral mode. Okay, and also a shortwave infrared band has been added with a spatial resolution of 20 meter, and there is a new sensor called vegetation. Okay, here, be careful that this vegetation is not the addressing the plants, the crops on the earth. It's the name of that sensor. Obviously, that sensor is good at detecting vegetation. Okay, so here is a comparison table among spot 1, 2, 3, 5, and their sensors. Okay, and again, another area for this sensor called vegetation. Okay, I'll just leave this table to you. Just compare them a little bit. You don't have to memorize anything here. Okay. Okay. Multispectral imaging using linear arrays. Next part, I want to introduce 3 commercial satellites. Okay. They all have very high spatial resolution, and they are ICONOS, OptView 3, and QuickBird. They belong to 3 companies. And their band configuration is similar. Okay, from violet to blue. So basically RGB and a little bit near infrared, because this is above 700 nanometer, right? And beyond that, the last band is a panchromatic band, which means it will take true color image of the ground, right? And ICONOS is using linear array push broom. OptView 3 is using body scanning whisk broom, and QuickBird is just like ICONOS, also uses linear array push broom sensors. Okay, and they were all launched around the new millennium, right? Around 2000, around year 2000. Okay, and here I have some sample photos from them. So this is a photo from ICONOS 4-meter true color sensor, or you can say ICONOS 4-meter panchromatic panchromatic sensor here, right? The spatial resolution of panchromatic is actually 0.82. So this is 4 meter, okay? So it's a combination of the other 3 or 4 bands, okay? Should be other 3 of other 4 bands. So you assign them R as R, G as G, B as B. So it's true color, okay? And this one is Iconos 4 meter false color photo for the same area. And here, typically, near infrared band, which should be band 4, is assigned red. So you can say there is a lot of vegetation here. They are all in red. Okay. And this is a quick bird 0.6 meter true color image. And the quick bird, like I said, all these commercial satellites, they were launched around year 2000. Okay, so today we even have better sensors. But just look at this. It's with a spatial resolution of 0.6 meter, you can clearly differentiate different cars here, right? And all details on roofs, they can be accurately identified. So, and this is for civil use. You can imagine the application of remote sensing in military use in terms of their spatial resolution and also spectral resolution. Okay, so sensors today, they are very advanced. And I would say that nobody can escape from them. Okay, but if you're talking about sensors that are observing the Earth using visible band, of course, if you can hide inside a room, they cannot see you. But thermal band is another story. As long as you emit thermal energy, they can see you. Okay. Okay, I will just stop here. In the next video, I'm going to talk about a little bit about spectrometry. Okay, thank you.